Hello, welcome to our channel for R programming. In this video, we will talk about stepwise regression for selecting variables using R. So we know in linear regression model, a major or very important question is which variables will be selected in the final model. And one approach is called stepwise regression. So in stepwise selection, variables are added or deleted from a model one at a time. So this is one at a time is the running of the model until some stopping criterion is reached. So usually there are three types of stepwise selection. So the first is forward stepwise regression. So in these kinds of model selection, you add predictor variables to the model one at a time. So the model will be more complicated each time. Then the model selection will be stopped when addition of the variables would no longer improve the model precision. And on the contrary, in backward stepwise regression, you start with a model that includes all predictor variables, and you delete variables one at a time until removing variables would not improve the quality of the model. And the third type is just called stepwise regression. In this kinds of approach, you combine the forward and backward stepwise approaches, and the variables are entered one at a time, but at each step, the variables in the model are re-evaluated, and those that don't contribute to the model are deleted. So in this approach, predictor variables can be added to or deleted from a model several times before a final solution is reached. So here we show one example for the backward stepwise. And in R, the function step can be used to perform stepwise model selection for the forward, backward, or stepwise. And the criterion is AIC, Akaike information criterion. So AIC as low as possible, which means the model is better and better. Because this criterion is combined the log likelihood fault model and the parameter included in the model. So this is a trade-off. And now we will show how to implement step function for the stepwise model selection. So here we use data frame, which select variables for murder, population, illiteracy, income, and flux from a data set state x77. So we store this information in a data frame called states. So if we show states, so states in the data frame have 5 column variables. So now, say we want to estimate the model of murder from predictor variables, and we do not know which variables will be included in the final model. So we can use, for example, a backward stepwise. We just select all the variables, all the other variables as predictor variable for the dependent variable murder. So we just fit this model, use linear regression function LM first, and with the data, states, and the variable on the right side of tilde symbol, and left side is murder, because this is dependent variable and these independent or explanatory variables or predictor variables. We just run, so the fit is done. So this is a model result type object. So next we can use step function. So step this fit and direction is backward option. We just run, see how it is going. and the result is quite long. So we should see step by step of start, which means the model starts the whole model, original model, with 4 variables. So this AIC is 97.725, and this is formula for this model. Then next part of the table shows each variable. If removed, then what will get their AIC. We know AIC is lower is better, right? So you can see the first float, if removed, then AIC of the model will be 95.753. So, and remove other models will get a higher AIC. So which means the first step, we will get the model removing floats. So the model will have AIC 95.75, and this is the model of the first round selection. And this AIC is lower than the original AIC. So we choose this first step. So we get the model like this, murder, and the independent variables will be population, illiteracy, and income now. So the second round is quite similar as the first one. Then if we remove income, we'll get AIC, this one. And remove other two will be higher AIC. So the model selection will go further of removing income variable from the model, and will reach AIC 93.76. So after second round, the model will be murder, a dependent variable, and independent variable will be population and illiteracy. Then the third round, because there are only 2 variables left from the end of second round. So if either of these 2 variables are removed, then we get this AIC number. So here you can see each one is higher than this AIC, which is the end of the second round. So this means in the third round, we will do nothing. We will not remove any variables more. So which means we will stop at the second round with this AIC and this model structure. So the final model is this model, and the coefficients estimation is shown here. Intercept and population and illiteracy. Thanks for watching.